Thank you to be here with us all together today. We are gonna speak about a very interesting topic, as always. It is addressing challenges in the fisheries sector with Earth observation. This interesting topic is very important for the Earth Center and also for the international community. Nowadays, there are concerted efforts involving many coastal states, regional institutions, and global bodies to develop and improve existing initiatives that focus on reducing the depletion of fishery resources and marine biodiversity, promoting marine ecosystem health, and safeguarding lives at sea. These strategies are most needed in many developing coastal nations and islands that are plagued with myriads of challenges that ultimately prevent these states from releasing the societal benefits the ocean offers. Weak governing structures, poorly resourced institutions, inadequate capacity to utilize geospatial data and technology, among others, remain the bane of many of the public and private sectors that have the mandate to ensure sustainable use of the ocean. We are today presenting a very prestigious researcher from the University of Ghana that through the EU funded Global Monitoring for Environment and Security and Africa project is supporting coastal states in West Africa to utilize the Earth observation data derived from spaceborne sensors to support fisheries management efforts. By engaging with policymakers, issues relating to changes in ocean processes and its impact on fish distribution, threats posed by illegal fishing and environmental distractions from spills of seas are being mitigated by employing geospatial technologies. This talk will provide some insights, as you already see, on how satellites imaging is being used in planning monitoring and surveillance campaign of industrial fishing fleets, generating key fishing effort indices, and providing periodic information on the state of the ocean to artisanal fishermen to reduce accidents at sea. Dr. Kwame is a marine remote sensing scientist for the University of Ghana and co-chair of the GEO Planet. He obtained his PhD degree from the University of Ghana in 2016. Kwame has been keen interest in using marine Earth observation data for fisheries management, as well as in marine security and safety. His work at the University of Ghana largely focused on developing coastal and marine services to support monitoring, control, and surveillance activities of coastal states in Western Africa to curb illegal and unregulated fishing using various in situ modeled and spaceborne information, such as fishing vessel traffic information from Automatic Identification System, AIS, ocean color, remote sensing data, and forecast products from Mercator Ocean to develop potential fishing zone maps to support fisheries management activities in West Africa. Please, Kwame, welcome you here, and we are keen to listen to your presentation.
All right. Thank you so much for having me. So I'm going to share my screen, then start talk for the day. Are you able to see my screen?
Yes.
Good. Thank you. Hello, everyone. Good afternoon from Accra, Ghana. Today, just like Alice had said, we're going to talk about how we are using Earth observation data to address challenges in the fishery sector, largely in West Africa. My name is Kwame Agyekum, and I'm based in the University of Ghana. So this talk will have these two key headings. We're going to talk about how, through the GMES and Africa project, which is an EU African Union funded project, we work with partners in West Africa to provide information on the state of the ocean and look at issues that affect fisheries resources. Then I will also hit a bit on some collaborative engagements and capacity building activities that we have been working on, because that bit is very, very important. You would have the issues, and no one is an island. You work with others, and through that you share information, share ideas, build on knowledge, and then you can do more. So I'll just delve into the talk for the day. So we all know we have a vast ocean. Africa has a coastline of about, let's say, about 30,000 kilometers or more. And the fringing ocean has enormous benefits. I mean, we can think of the use of the ocean for transport and for commercial activity, oil exploration. In some parts of the world, we have wind farms on them to generate electricity. And for us, especially in developing countries, the ocean being home to fishes. I mean, in almost every home around the world, fish is probably eaten, and it's a major source of nutrients. We derive a lot of health benefits from eating fish. So it's important that we continuously monitor how our activities impact on their abundance and distribution. To achieve this, for instance, the African Union has an agenda 2063. Basically, the whole idea is, how do we safeguard this resource? How do we ensure that this resource can provide us a lot of benefits, right? So on this slide, we can see a plot on our right with a lot of pie charts. What it's saying is that there are different types of fisheries. We have inland fisheries, we have marine fisheries, we have industrial fisheries, and even aquaculture. How are these different sectors contributing to the GDP of the country? You can see that most countries in West Africa largely rely on the artisanal sector, and I will explain that at some point in this presentation. For food and the sale of fish. In the inland countries, obviously, aquaculture and inland fishing from lakes and rivers is critical. But for most coastal states, the ocean becomes the main source of fish. I mean, it's vast, it's very productive. There are quite of upwelling centers dotted around the coast of Africa. So it's easier to find fish from that medium. To this end, for instance, the World Bank sees that it's important we ensure that fishing is practiced sustainably. So there's been a lot of initiatives and projects starting way back in 2010 or so, where 2005, where a lot of funds were made available to manage resources. For instance, in Ghana, we were part of the WAF project, where we received some money. The Ministry of Fisheries and Aquaculture Development received some money to ensure that policymakers understand the importance of the ocean and that they develop better rules and that can ensure that the resources are managed. That we have an effective vessel monitoring system so that when fishermen go out to sea and they fish, you are able to know they are doing the right thing. You ensure that they are catching the right size of fish, they are not overfishing the stocks and so forth. So the point that I want to make is that the sector is so important, but again, it becomes very, very difficult to manage because one, it's vast, and two, you don't expect everyone to do the right thing. Not everyone understands that the sort of things we do at sea could affect the number of fish we have in there, the type of fish we have in there, and hence we will not be able to make gains out of the resources in there. So on this slide, I want us to look at some challenges that we face, especially in developing countries and in West Africa. There are some of these challenges that are beyond us. For instance, environmental impact and climate change. I mean, when I say it's beyond that, it's not as if our day-to-day activities directly, impact the type of fish and the number of fishes we see there, right? As the ocean gets warm, we expect that it gets stratified and that there is reduced nutrient availability to drive fish growth. But again, there are quite a number of things that we are more or less affecting how fish would grow and where they would go. For instance, illegal fishing from IU fishing, illegal, unregulated, and unreported fishing, and piracy. It affects how many fishermen can go to sea. That is piracy, because they tend to get scared to be at sea fishing, so they wouldn't go to fish. So we wouldn't find any fish on our table as food. Through illegal fishing and unreported and unregulated, we tend to affect the sort of interactions that we would normally have between fishes and for fishes to grow and the environment. So again, the number of fish that we would find will reduce. There are instances where countries don't do proper enforcement. They don't have the right governing structures and management policies. When that happens, the ocean becomes like no man's land. Everyone goes out there, does anything he wants. Then obviously you wouldn't have a pristine environment for fishes to grow. There's also processes emanating from land or certain operations at sea that tends to pollute the ocean and degrade the environment. When all of this happens together with overfishing, you tend to lose a lot of marine living resources, and you don't have enough to feed on. So let me bring us home to West Africa, where I want us to know the type of fisheries and fishing vessels that we have. So we have an artisanal fishery sector. This area is largely, you have a lot of coastal communities engaging in this. So you have a lot of fishing sites dotted along the coast of West Africa. Fishermen from those communities go out to sea in very tiny crafts, like the canoe you see up here. Sometimes the canoe can take up between, let's say, sometimes 5 to 25 people. They may sometimes be between 10 to maybe 20 meters, 25 meters. And those fishermen that use this boat and the fishermen in this sector largely do this for subsistence, right? The food that they get, or the fish they get from the ocean, is just to feed themselves and their families, and to sell a little bit more for something small for their upkeep. So it tends to provide employment. It's a source of livelihoods for fishermen. Again, we have another sector we call the semi-industrial fisheries. Here you have some sort of motorized boat. I forgot to say that most of the time the canoes are also motorized. They are motorized outboard motors. But then we have the semi-industrial boats, which are slightly bigger and wider, and they have sometimes refrigeration on board. They have slightly bigger engines, so they're able to go out and stay very long at sea. Then we have the industrial sector, which are huge ships. They have huge storage. They can stay for months at sea, right? So these are the sort of vessels that operate within the ocean space in West Africa. But I'll be quick to say that not all of the, let's say, 14 or 15 coastal states in West Africa have all of these type of fishing boats. Some do not even have industrial boats at all. You don't have any industrial boats registered to them. For instance, in Ghana, we have close to 400, and about 120 are actively engaged in fishing. That is the semi-industrial boats. Then we have about 40 or let's say 30 industrial boats registered to Ghana engaged in fishing. So, like I had indicated earlier, there are a lot of issues. So at the University of Ghana, we work together with 7 partners from Senegal, Benin, Nigeria, Cote d'Ivoire, Cape Verde, and Togo to develop services that can safeguard the ocean, promote growth of fish, and improve coastal ecosystem and habitat. So I'm going to talk about 1 or 2 of these services. I mean, I don't think I have time to talk about all 5 of them. So we'll talk on how we're using Earth observation data for mapping fishing zones and for IUU monitoring. How we are also using forecast products and some ocean products to determine the state of the ocean and to provide alerts for fishermen before they set out to sea. So the first service that I'm going to talk about basically describes how we are using satellite imageries to help curb illegal fishing by mapping potential fishing zones, then also collecting vessel traffic information to understand how vessels behave and to know where they go, so that we can safeguard lives and reduce IUU fishing. So the way we do this is to collect information on the state of the ocean. That is how warm the ocean from sea surface temperature data set, ocean color. From that we can know the greenness of the ocean, and it's a proxy for phytoplankton abundance. When I say phytoplankton, what I'm referring to, the very, very tiny plant-like organisms that occupy the surface of the ocean. So they grow, then think of it this way, they grow, then the herbivorous fishes feed on them, then other fishes feed on the herbivorous fishes and so forth. So they become an essential component on providing energy within food chains within the ocean. So we use ocean color to look at them. We also look at other parameters such as surface height, current, and so forth, because all of these ocean processes tend to determine how productive the ocean will be. So by measuring them and relating them to productivity, you are in a better position to know how the ocean is changing and how productive the ocean will be, and probably how much fish you find on your table. So we analyze these using a lot of open source tools, and it's very, very important in building this service, because you don't want to be spending a lot of money buying software that are expensive or difficult to maintain. And so as part of the way we engage and develop this service, we train people, and I will come to that to use for these things. So a lot of image processing goes on to tease out features that are critical to life within the ocean, such as upwelling, ponds, eddies, and so forth. Then we put all of these together and we relate that to fish distribution. But in the next slide, I will explain that better. We also acquire vessel traffic information, because one, you want to know what a vessel is doing. So you want to track, understand its behavior at sea and all of that. We set it up, build data management systems that will store, then we analyze to detect certain activities of interest. The way this service is also set up is that we disseminate this information either via our portals. We have a GEO portal or a website. Recently, we developed an app that we allow people, certain people, not everyone. So this service is not tailored for everyone. It's designed largely for fisheries managers, especially scientists or engineers or fisheries managers involved in monitoring and control and surveillance. People who need to know where fishes are so that they can ensure that it's policed. The fishes in West Africa are almost depleted. So we don't want to tell people where to find fish to go fish. We actually want to tell people who police the ocean, like the Navy, the Coast Guard. This is where we think there will be fish. So it is likely fishing vessels will move to those places to fish. So go there, keep an eye on them. That is the philosophy behind this service. Again, we also have a system set up where we send this information to emails for certain institutions and targeted people. So they receive them at a certain specific time of the day, and it helps them in planning their fishing campaigns. We like to improve the service, so we always want to get feedbacks from our beneficiaries. Now, this is how the potential fishing zone map predicting tool works. Like I had indicated earlier, when we collect all these environmental data sets, we want to know where fishermen fish. Ideally, we need to use a lot of logbooks and catch information from logbooks. But what we observed when we started designing this service was that most people don't, or most fishermen, sometimes because they are not properly educated or they don't have the right systems, do not collect or report the right information on where they are catching the fish and the type of fish they caught. So we designed this service to utilize vessel traffic information. Now, vessels do basically three things. I mean, fishing vessels, they do three things. They are either at port, waiting to go to sea, or you find them steaming, taking it like a relatively high speed, using a straight course to move to their fishing grounds. Then three, they would, within the fishing grounds or fishing areas, they slow down to fish. They stop or they slow and they move haphazardly. So by knowing this, we can be able to look at how they are behaving from their speed information, course of ground information, and so forth, to identify the places they go to fish. Then we can then superimpose these on the environmental data that you see on your screen, then extract the conditions, the environmental conditions from those fishing areas. That becomes sort of a training data set to build the models. So in this image on your screen, you can see the cyan dots in the image. Those are fishing spots, and we extract those information, put it in a model, a generalized additive model, then predict areas that we think we can find fish and areas that do not have the optimal conditions for fishes to aggregate. So it's very, very simple. Now, when we have this setup, we are able to then generate each day by feeding the conditions for that day into the model to predict the fishing ground. It's as simple as that. Now, after generating these maps, we share them with people involved in monitoring and surveillance, so that they can help them to plan their fishing their monitoring campaign. Like I had also indicated, so vessel traffic information from AIS or VMS, it's an example of an electronic monitoring system. But what we also realized was that electronic monitoring has or was designed largely for industrial boats. These are boats that have power on board, right? So they are able to run these equipments, these Class A transponders. Then we collect the vessel traffic information. But we realized there was a big gap in the artisanal sector and the semi-industrial sector. These boats did not have any tracking devices. So that challenge we needed to overcome, right? And we also had to build capacity for fishermen to be able to use that. So I'll show you a few slides that would explain how we engage to get that done. Again, by using electronic monitoring, it's so easy. You can see that there's a satellite in space. I can sit anywhere in my office or anywhere at home. and I'm able to understand and know what vessels are doing. That was one of the coolest thing we did, because it allowed us to remotely look at vessels. One other challenge that we also found or persist in managing or in monitoring and control activities is putting men on fishing vessels to know what fishermen are doing. We call that the observer mission. Over some time, we have been doing that in Ghana, but it seems that approach is costing us a lot, not in terms of money, but in terms of the lives of the observers. We have had a lot of instances where observers go to sea and they don't return. The man always come giving us stories. Either the guys are missing, they are drowned, or we don't know. So it's not something we have to keep doing. But again, we can also, but I'm not showing that in this slide. We can start thinking of using, and it actually exists, using video cameras, having them on board to be looking at what the fishermen are actually doing. That would allow you to know even the type of fishes they are catching, the quantity, and whether they are even using dangerous chemicals or unapproved implements like small mesh sites and so forth. So that is another way to use electronic monitoring and Earth observation to support or to curb illegal fishing. Back to the issue about artisanal fishermen and the semi-industrial fishing fleet. These boats that you see here are locally made in Ghana. And for instance, the one on your extreme right is a canoe, and it's powered by an outboard motor, and it doesn't have any battery on board. So one of the things we did with the Class B transponder, the orange device you see on the left, which you can actually charge, then put on your vessel, move to sea so you can be tracked, or we tried using a solar panel, and it worked ideally. So what it means is that it's very practical now and very feasible to put these devices on boats and get them powered and be able to track small boats, canoes, 24 hours a day, 7 days a week, 365 days a year, right? And in the past, we were not doing this. So what this means is that we can now also, not just the industrial boats, look at the small canoes and understand how they behave, and also detect if they are also involved in infractions at sea. So in doing all of this, together with the small boats, the semi-industrial boats, and this industrial fleet, fisheries managers and enforcers have enough information on fishing operations. One, we can analyze these data sets to identify fishing areas, or like you can see from the fishing density maps, you can know where for a day or for any particular period fishing occurred. And this is good information. Before this project, we were not doing this. We can also analyze to know the countries the vessels are coming from. We can look at their sizes. We can actually monitor and know whether they are operating in areas that they are not supposed to. For example, if you want to have any closed season, this becomes the go-to technology. If you want to map protected areas, the go-to technology. We can actually even analyze the data set to identify certain IUU infractions like transshipment. When vessels, it's illegal for vessels without permission to move together at sea, take one catch from one vessel to another and transfer or transport to another place. It's not acceptable. You can actually use AI's data to detect, or VMS data to detect these infractions. We can know how long these vessels had stayed together, where they had engaged in these infractions. And in some cases, we have actually done targeted monitoring and generated reports for some of our partners where we looked at a particular vessel and looked at its behavior, what it had done, we gave details on all of the activities of the vessel. And in this instance, this vessel was involved in IU, and we needed to generate a detailed report. And the system allows us to do that. So there's so much that IU, BMS, AIS can do for us. I spoke to you about how we are able to monitor canoes. But let me give you the story behind how we were able to convince fishermen and even our ministry in charge of fisheries to do this. It's no secret that a lot of these small boats are involved in IU fishing. They are involved in sometimes even in drug trafficking. They're involved in transshipment. They carry sometimes explosive chemicals and so forth. So we needed to have a strategy to look at what they do. Again, because their boats are very small, weak, and so forth, we also had to have a strategy to ensure that their lives they operate safely at sea. So from the ministry side, the government agency side, they needed to monitor. From the fishermen's side, they wanted to be safe at sea. So we spoke to them and educated them, engaged them at different fora around different places in Ghana, and advised them to start thinking of using Class B transponders. So this is if you look at the middle picture, there's the gentleman carrying that orange device, and on the left, you can see us putting the transponder on some of the boats. So we were able to we got them to buy into this technology and approach, and it worked. We installed, then started monitoring. So we, together with a company from Canada called Exact Ed, started monitoring these small boats. Until then, we didn't know. Obviously, we know they go to sea, but we didn't have a fair idea exactly where they were fishing. And if you look at the chart down here, you can see those blue dots. Those are trajectories for a particular vessel for some period, and we could easily know where it was fishing. We overlaid these tracks on bathymetry data, and we knew where they were fishing, and the depth at which they were operating, and so forth. We were getting a lot of information that in the past we never had. The point I want to make is that small vessel monitoring is very, very important, especially when you have a large number of your fishes in that sector. And thanks to Class B transponders, we were able to map that. We analyzed to generate fishing effort indices and so forth. And that approach worked. Unfortunately, it was a bit expensive maintaining that technology. So currently it is not being used, but there are, and I'm not showing that slide today, but there are ideas to start thinking of small sensors using Internet of Things and other long-range receivers to track these boats. So this picture shows how we engaged policymakers in West Africa, and we actually recommended, and in some of the countries, they also tried it. In Gambia, I think they did that. In Togo, I think they also tried doing that to start using small, Class A, Class B transponders on small boats and to monitor. The picture here shows how me and some fishermen, and these are people that we work together. Again, apart from using vessel traffic data, we are also using satellite imagery. So this is over here. I'm showing you examples of how we're using high resolution optical images from Sentinel-2 and radar images from Sentinel-1 to detect ships at sea. This is not only for fisheries applications. I mean, we can use it for maritime security and so forth. So the point is, it's if you don't have AIS, you don't have funds to run AIS, VMS, and so forth. Sometimes optical images and radar images, which is freely available from the Copernicus program, can be used for fisheries management. Apart from monitoring activities, tracking, we also use some of the model products from Mercator and other data sets to help fishermen to know the state of the ocean. So what happens is that we analyze these data sets, identify days and areas that have bad weather, and we communicate this to fishermen. So most of the fishermen in West Africa, quite a number of them are not literate, so they will not be able to read. So we thought of using numbers and colors of flags to communicate this service. So one fisherman who probably might be educated has a phone. We send this to him by text. Say 1 is calm, 3 is rough, 2 is 3 is dangerous, 3 is rough, and he is able to communicate to his colleagues either by changing the flags to suit the conditions for that day, and they know whether it's safe to go to sea or not. So this is how we simplifying technology to ensure that fishermen stay safe and utilize what they couldn't have been able to use in their day-to-day operations. One key thing that I want to point out here is it is important to do this all of this in collaboration. So we rely on certain institutions for data. We get ideas from other projects. We engage others for technical support. So we are not completely experts, or we don't have all the expertise. Sometimes we also work with other institutions, for instance, the JRC in Italy, to develop some of these services. One of the initiatives that I wanted to also start thinking about is, or to think about the approaches, is GEO Blue Planet, where I'm a co-chair, and we basically form networks of scientists, data providers, institutions with expertise and funding to make ocean measurements. Then we work together, understand problems, build solutions together to ensure that we can get the best out of the ocean. So there are a lot of activities that we are involved in that I also need you to start thinking about. And in case you want to be part of any of this, you can visit their website and engage, or let us know what the issues are, and we're very, very happy to work together with you. So for instance, we are looking at issues relating to fisheries, marine litter and pollution, hazards at sea, Earth observation applications for disease control, capacity development, training in all aspects of issues that affect the ocean, sometimes even in governance, and also creating awareness on the importance of the ocean. On your right, there are a lot of projects like I had indicated, and feel free to go to the website of GEO Blue Planet and sign up for some of these assistance. Again, to also build a vast network of institutions, scientists, and so forth, there's the Oceanscape tool available where anyone can go to know what sort of collaborations exist, which institutions are working together, what are their capabilities, and so forth. Then you can also sign up and join so that it's easier for someone to also know what you are doing. So I would entreat those of us listening to this talk to visit the website. And if your institution is involved in anything related to the ocean, please sign up. All right. So this will be my last slide. I have talked about skills, the use of satellite data, and so forth. One of the key things that is important in developing and building this sort of system is ensuring that people that you work with are on the same page with you. So for us, we take training and capacity building and awareness creation very, very important. And over the years, we've trained a lot of people in West Africa. We have also participated in a lot of workshops, seminars, and meetings, pushing for institutions, especially fisheries institutions and environmental institutions, to start thinking of using Earth observation data to support their day-to-day activities. So this will be the end of my talk, and thanks so much for your attention. Alice, you're on mute.
Sorry. Thank you very much for your presentation. It was wonderful. If you have any question, you can write them in the Q&A. I already received a number of questions from different sources, so I will start to read some of them. And the first one is from Brazil, and it is, how can we apply this technology to other regions in the Atlantic? I think it's simple like that.
Okay, all right. Question from Brazil. So one of the things that I failed to say is that the sort of service that we are producing or like generating, it's not just for West Africa. There are other institutions also doing that around Africa. And even in Europe, they also have similar projects. So it's so easy for one institution to say that these are my needs and that it can be transferred to you easily. And in the balance of this continental-wide project, we call it cross-fertilization. It's so easy for you to get in touch with us and say, these are our needs, and we don't have the expertise or we don't have the processing skills and tools. Already, like I indicated, we are using open source too. So it's so easy to take it up. The data sets for these services are also freely available, especially through the Copernicus program. So anyone can say, this is what I want to do, then get in touch and very happy to assist. And it's also not just for oceans. Under the GMS in Africa project, there are other services and applications for the terrestrial environment. So if you should ever Google GMS in Africa project, Africa, that sort of thing, all of them will pop up and you will know the institutions to talk to and the sort of services that are available for you to take up.
And now this is the challenging one, I think, for this topic. How can you link your system with enforcement agencies to tackle illegal and unregulated fishing? And how do the fishermen also responded to your project, in the sense that they will feel probably controlled or something like that?
Yeah. All right. Already, most of the institutions involved in monitoring and control and surveillance are sort of handicapped to use satellite images. So there's a big need for what we do. Some of them do not have the capacity to analyze imageries. They don't have the capacity to even assess some of these imageries, and even the computing power to process the imageries. We need, most of the things that we generate is a hot cake. So there's a big need for the service that we generate. The sort of information we generate are so useful to them. So there is no bottleneck in this case. There was a second part of the question. If you can repeat it.
How the fishermen responded to your project?
Oh, yeah. So at the beginning, it was a bit difficult, and it's normal because they were not clear in their mind what we were doing with them or the sort of benefits we were bringing to their table. Then when we had time, engage, and I'm going to say this to everyone listening, in developing these things, it has to be, you take the co-design approach and ensure that you listen to what their needs are. And that is what we did. So we engaged, listened, and we knew exactly what they needed. Then we developed that together with them. So you realize that I had, like I had indicated, the safety at sea service, we had to simplify it. I mean, the fisherman sometimes doesn't need you to be saying, giving him a whole bulletin. All he needs to know is it's not safe to go to sea within this area. And that's what we did. We then even decided to use numbers, then colors. So you need to engage, get feedbacks from them, and that would allow you to develop something very, very useful to them.
Perfect. Someone would like to know what is the state of marine spatial planning in Ghana, and if it can help your work.
So I have been involved in some seminar meetings and so forth, where we are developing this. I don't want to say that it's an efficient system when it comes to marine spatial planning in Ghana, but our access to satellite imageries, vessel traffic information, and generally geospatial data and tools puts us in a very good position to build on that, right? My institution, the University of Ghana, the sort of products that we generate is very useful for some of the things that they do. So we are in contact, in constant interaction and in contact with them to be able to help them develop something that is very, very useful. Yeah.
Okay. And regarding the GEO Blue Planet initiative, how other stakeholders could participate in this from the Atlantic?
So it's so easy. You could always send me an email and I could hook you up with an institution or a body that could be of use to you. So for instance, if sargassum monitoring is an issue in your marine waters, there is a project looking at that, and they want collaborators and beneficiary institutions. And it's just by an email or visit the website. You will know who exactly you can reach, and that is as easy as that. There are Twitter accounts for my project, for GEO Blue Planet, Facebook accounts. Just go there and let us know what you need, and someone will come to assist.
Perfect. Now I have some more technical questions about your models and your analysis. So the first one, I would like to have more details about the model to map the potential fishery zones. I don't know if you can add something more, or maybe some references, etc.
Oh, there are lots of references out there or papers out there that explain that. I think there's one called by Saito et al. They are based in Japan or so. That paper was probably written in 2015 or so. It explains the approach. I have Python codes that are freely available that I'm ready to share. So in case you want that, just send me an email. I have a small paper that also describes that. So the technique it's basically machine learning, where you identify areas that people had fished, you take the environmental conditions, then you also identify areas where no fishing occurred. Then you put it into the model. It breaks it into bits and pieces and look at the nonlinear relationship between where fish was found or fish wasn't found and the condition. Then it gives you a probability map that says there's a high chance, a 0% chance or 100% chance that you might find fish here. The product that we also generate is able to tease out certain features like eddies and fronts and even upwelling centers. And if you're an oceanographer, you just look at it, it gives you a fair idea that, oh, conditions are right out here and we think fishermen will go there to fish. So it isn't so complicated.
Perfect. Is the ECOWAS marine program also looking at coastal aquaculture, either for planning purposes or monitoring for habitat changes?
No, that isn't our focus. But I mean, there are experts, especially at the University of Ghana, who can also assist with in doing that. So we are not looking at that currently. But as part of the project, I think yes, CSIR in South Africa, who is another sister organization, is also doing that. So they will be able to help with that. In case you need any assistance in that respect, just let me know. I can connect you to Mary Smith. I think Mary Smith is even here. Yeah, she's listening, so she could be able to help. Yeah.
Perfect. Someone wants to know if you have looked at correlation between AES vessel position information and the SAR vessel locations to know how many of the vessel fishing off Ghana and the West are running with their AES turned off.
Yes. So yes, I didn't show this, but I mean, for a lot of security applications, it's good to merge or fuse SAR images with AIS data. And I'll quickly try and explain the approach. Sometimes some of these images you acquire from SAR are tasked. In some cases, they are not tasked. They have a pass time, acquisition time. So they cut across your coastline and you collect the image. What is important is anytime such images are collected, you know the date and time stamp. When you know this, you go get the corresponding AIS data for that area and for that time. After doing that, you can detect, for instance, there's a tool called SNAP, developed by European Space Agency. It has tools for generating or for doing AIS analysis, or you can write your own codes. You have a constant false alarm rate, you have a moving window, you can detect ships from SAR, then you can fuse and see the correlation. It's something I have done. Quite a number of the detections that we see from images fuse with or seems to correlate with some AIS data. So your detection from SAR can tell you the size of the vessel. It doesn't tell you the name, but it can tell you the size, the width, and sometimes even the orientation. And from AIS, you can get the name, the size, the length and width, the direction it's moving in, and even the speed. And you can use all these parameters to estimate the correlation. So it's doable. I didn't show that in this presentation, but it's one of the things I'm working on now.
And what do you think roughly is the proportion of the
so what I have been working on, what I've realized is that depending on the concentration of vessels that you have, right, especially with AIS, when you have a lot of vessels concentrated, then most of them don't report to the satellite in space. So it's likely you would have poor correlation. But when you have a vast area with few vessels, they report their position, and it's most often than not, the correlation gets better. But sometimes some of the vessels also turn them off. And when they are off for a very long time, then obviously these are vessels that might be engaging in illegal activities. It could be either related to fishing or piracy or terrorism and so forth. I mean, we don't have to go there now.
Yeah, exactly. Okay, so someone would like to know more about the partnership with Exact Earth, if it's still going on, and what is the maintenance of the tracking devices result?
Very, very good question. Very good. So I like the bit about maintenance. So the devices were not produced in Africa. So somewhere in Europe and America, they do that. But the good thing is that those devices are not too expensive, right? So if you want to go that way, you should buy enough, have them stored so that you can constantly go and replace. But ideally, 5 years, 10 years, you'll be fine, because those are like waterproof. They can withstand the harsh conditions at sea, so you'll be fine. I mean, they are watertight too, so the terminals are very, very protected. So they are not going to rust, so they would last a bit long. The sort of partnership or collaboration between Exact Earth and us is they provide us with data, right? It's a commercial entity, so we pay some money for that. But in case you want, as a country or institution, you want to also use their service. It's there. They have a very nice portal where you don't have to install anything. It's web driven. So all you do is you sit behind your laptop and you can look at vessels of interest. You can sign. There are different licenses, so you can sign up for different ones and get different costs. I mean, it's not too expensive to use that service too. So in case you are interested, you can also get in touch with me. I can connect you with to them.
Perfect. And the last observation was more like a comment is, of course, so you are trying to give AES transponders or VMS or other kind of transponders to the fishermen, but the ones that didn't have it before, or even if you give it to them now, they will switch it off when they will engage in illegal activities. So how can we solve this problem?
So that is why you don't use vessel traffic systems in isolation. It's important you blend it with satellite imaging, and that is what I try to explain. And if you have the money, go buy a drone that can go far, that is seaworthy, or maybe get your country to buy a chopper or an airplane. Then in case you realize that a particular vessel is off and you have satellite imagery to go with it, you can then fly there and do better inspection, right? So this is how you combine these different platforms to be able to have a very good eye at sea. I would like, let me put it that way, to have a very good eye at sea. Yes.
And now, a curiosity from my side, I would like to know which is the order of magnitude of illegal fishery in Ghana's waters that is from foreign countries, and which is the proportion that is from Ghana's boats.
Okay, so most Ghanaian boats work together with the vessels from outside. I mean, the international vessels also move in to do a lot of patrolling and transshipment, right? So fish is transferred from one international vessel to the other. A lot of transshipment happens that way. Then some small boats from Ghana also move and work together with some international boats to collect bycatch and discards. So these are the major infractions involving these different group of vessels that we observe in our waters.
Mm-hmm. Okay. Let's see if I have new questions. No, I just would like to add that there is also the potential collaboration with all the GEO MBON program. If people are interested, work with it. MBON is mostly focused on the biodiversity monitoring and studying and tracking, etc. So for openly sharing data and also capacity building to improve the standardization of the protocols, scientific protocols, but also data analysis and the publications. So just to remind you that is also very in line with the GEO Blue Planet objectives.
Yes. Yeah.
And I think I don't have any other questions. So maybe we can close now these exciting sections. And if the people are still curious to know more about the work of Dr. Kwame, they can write directly to him. Right, Kwame?
Yes, please. Yes. So my email has been shared via the chat, so you can always get in touch.
Okay, perfect. Thank you very much to all of you to have attended this again, this session of the Networking Fridays from the Earth Center, and see you soon next week.
Thank you all for having me.
Thank you.